Hey everybody, hope you're doing well. Welcome to another Fix Your Gut live stream. I'm your host, John Brisson. Today we're going to discuss a common food additive that is bad for your health. It is the brown seaweed extract Carrageenan, which is used as a thickener. It's used to thicken up foods. You'll see it listed in a lot of prepared gravies and sauces or plant-based milks like almond milk, coconut milk on the label. You'll even see it applied to deli meats. And it's not healthy for you to ingest Carrageenan. So here we have an advocacy group called the Cornucopia Institute. How did Carrageenan get into your organic food? Anyway, we're going to discuss that it's now listed in organic food. That was put forth by the Trump administration. And so yeah, we're going to learn about why Carrageenan is bad for you. USDA decides to allow Carrageenan in organic food despite health concerns and votes by the National Organic Standards Board April 4th, 2018. Washington, D.C. The U.S. Department of Agriculture today took another step to undermine the integrity of the United States Department of Agriculture organic label on food by reauthorizing the use of Carrageenan, a food additive whose safety is questionable according to Consumers Union, the Advocacy Division of Consumer Reports. Studies have indicated that it can cause gastrointestinal inflammation, and laboratory research in animals has shown ulcerative colitis-like disease and intestinal lesions and ulcerations in some animals. The USDA's decision comes after the National Organic Standards Board voted in 2016 to remove Carrageenan from a list of ingredients allowed for organic products. This is no longer considered essential, after they heard substantial testimony about its potential health impacts. The decision by the USDA represents a troubling precedent that undermines integrity of the organic label, says Charlotte Valleys, senior policy analyst with the Consumers Union. Current law requires the USDA to base the national list of allowable ingredients for organic food on the recommendations of the National Organic Standards Board, which are developed after extensive public engagement and stakeholder input. The USDA's decision to ignore NOSB's recommendation raises serious concerns about the future of the organic label. The National Organic Standards Board is a 15-member citizen advisory board established by the Organic Foods Protection Act. The federal law also requires that foods with the USDA organic label contain at least 95% organic ingredients, and the remaining 5% are thoroughly reviewed for safety and other criteria by the NOSB. This is meant to establish a safeguard to ensure that decisions are made with broad stakeholder input and are not ultimately decided by the U.S. Department of Agriculture in response to lobbying by a handful of companies. For several decades, the USDA has faithfully implemented its recommendation on changes to the national list as required by law. Carrageenan has no nutritional value. Rather, food processors add Carrageenan as a stabilizer to change the texture, structure, and physical appearance of foods like dairy foods, plant-based beverages, and lunch meats. The Organic Food Protection Act of 1990, OFPA, requires that prohibited materials may be added to the national list for a 5-year period only if use of such substances would not be harmful to human health or in the environment, and only if it's considered essential because no alternatives exist. Given consumer demand for organic foods without potentially harmful ingredients, many companies responded by eliminating Carrageenan from their organic product formulations, demonstrating that alternatives exist and Carrageenan is not essential. Like if you buy the organic lunch meat, for example, they use potato starch. It's a thickener, works fine. The National Organic Standards Board, after consultation with consumers, producers, and retailers, voted in November 2016 to prohibit its additive in foods with the USDA organic label. Last month, the USDA withdrew a regulation developed over 10 years by the National Organic Standards Board in consultation with organic consumers and producers that have assured consumers that meat, poultry, dairy, and eggs labeled USDA organic came from animals raised on farms that meet the highest standards for animal welfare. Chicken producers who could not meet the new standards lobbied for the withdrawal. The role of Carrageenan and carboxymethylcellulose in the development of intestinal inflammation. Study 2017. Crohn's disease is a chronic relapsing and remitting inflammatory bowel disease that has caused damage to the mucosal lining of the gastrointestinal tract, resulting in abdominal pain, bloody diarrhea, intestinal ulceration. After progression towards stricturing and penetrating complications required surgery, malnutrition, impaired growth, disability, and even mortality. Now, I have a video and a blog about what I believe to be the true cause of ulcerative colitis and Crohn's disease, which is Mycobacterium avium paratuberculosis, which is a mycobacterium found in ruminant animals. I've coached many people with ulcerative colitis and Crohn's disease into remission. using that principle. There are also co-infections involved. There's yeast, there's bacteria, Klebsiella, for example. And of course, I'm not a medical doctor. I am not a healthcare professional, but I am someone who's knowledge in gut health. Of course, run any advice I give you through your healthcare professional. Epidemiological studies have shown an increased incidence of inflammatory bowel disease composed of Crohn's disease and ulcerative colitis, both in areas of the world where the disease has been originally more prevalent, North America, Australia, and Europe, and in countries where IBD was previously infrequent, Asia and South America. It's noteworthy that this increase has occurred in conjunction with a transition towards a Western diet, characteristically high in processed foods and fats and low in fruits and vegetables. Although the exact etiology and pathogenesis of inflammatory bowel disease remains obscure, I disagree. There's tons of studies to show it's caused by MAP. It's believed to result from a combination of genetic, microbial, immunological, and environmental factors. Yeah, I agree with that. Clean diet. In the last couple of years, the field of nutrition and inflammatory bowel disease has advanced substantially, with several dietary aspects of interest, including the food additives used to induce intestinal inflammation, ulceration, and animal models of inflammatory bowel disease. Food additives are substances intentionally added during production, processing, packaging, transportation, or storage of commercial food products. Carrageenan is the name referring to a family of high molecular weighted sulfonated polysaccharides extracted from seaweeds. It commonly uses a thickening and emulsifying food additives to improve the texture of commercial food products, including infant formulas, dairy products, milk alternatives such as almond milk, processed meats, and soy-based products. First patented in the United States in the 1930s, Carrageenan's use as a food additive in the Western diet has substantially increased over the last 50 years. Carbomethylcellulose is a derivative of cellulose, making it affordable and abundant with thickening and emulsive qualities. It's found vastly throughout the commercial food industry, with a progressive annual increase in uses of food as a food additive. The role of carrageenan in intestinal inflammation in animal models. It's been demonstrated that when guinea pigs are supplied with degraded carrageenan in their drinking water, ulcerations develop in 100% of the animals in the large intestines by the end of a 30-day period. Lesions induced by carrageenan in guinea pigs' large bowel resembles features of human ulcerative colitis. Carrageenan has produced ulcerative lesions in rabbits, mice, and rats. They're associated with weight loss, anemia, diarrhea, visible or cold blood, and sometimes mucus in the feces. Further, microscopic features remnants of human ulcerative colitis, such as ulceratives predominantly limited to the mucosa, along with pseudopolyps and polypodial formations, were observed, as well as features commonly seen in Crohn's disease, such as strictures in the small intestine leading to obstruction. Histological changes associated with exposure to carrageenan in animal models include acute, subacute, and chronic inflammatory changes in the mucosa, occasional crypt abscesses, cystic dilation and distortion of the mucosal glands, mucosal ulceration, and various stages of progression and healing, and hyperplastic changes in the glandular epithelium. Precolo et al. Noted that animals fed a 2% solution of carrageenan mixed with standard rat chow developed small bowel lesions first from 2 to 6 weeks, followed by colonic lesions that developed after 8 weeks, which may be of particular interest for the subgroup of human Crohn's disease patients who extend their disease location. In recent years, evidence from animal studies have been mounted to suggest that the gut microbiome plays a critical role in the development of inflammation in response to exposure of carrageenan. For example, guinea pigs fed degraded carrageenan developed cecal ulcerations within 21 to 30 days after carrageenan treatment, whereas germ-free guinea pigs fed carrageenan for 6 months or more did not develop any intestinal lesions. Concurrent treatment of conventional guinea pigs with carrageenan and metronidazole, which is Flagyl, an antimicrobial primarily active against anaerobic bacteria, has been shown to prevent development of intestinal ulcerations. Consistent with recent reports in human inflammatory bowel disease, microorganisms such as Bacteroides vulgateus appear to play an important role in the development of the experimental ulcerative lesions in animals. For example, animals who are immunized with Bacteroides vulgateus prior to carrageenan administration develop experimental disease at a faster rate and more severe lesions in animals that were administered carrageenan alone, mirroring the development of antibodies to components of the intestinal microbiome in human inflammatory bowel disease. Oder Donk et al. Noted that non-immune carrageenan recipients develop antibodies to Bacteria vulgateus during carrageenan treatment, implying that an adaptive immune response occurs in animals following carrageenan-induced intestinal ulceration. Factors present on the bacterial outer membrane may mediate these antibody responses, as one study assessed 8 strains of Bacteroides vulgateus. Observed that alpha-phenon, term used to reflect strain variation of outer membrane proteins, was associated with enhancement of colitis. A specific mechanism by which carrageenan induces inflammation in experimental animal models is not clearly defined, but carrageenan has been demonstrated to decrease the amount of epithelial glycoproteins in the colon. and is capable of inhibiting the interaction between macrophages and lymphocytes. The involvement of toll-like receptor 4 and interleukin 6 in innate immune response to carrageenan was demonstrated using TLO4 and myeloid differentiation primary response 88 deficient mice. Recently, we et al. Showed in trintiobenzoic sulfuric acid model colitis in BLBC mice with pretreatment of carrageenan aggravated the severity, both clinical and histological, of TNBS colitis with a concomitant increased expression of interleukin 6 and tumor necrosis factor alpha, TNF alpha, and reduction of interleukin 10. Taken together, these animal studies have led to a hypothesis that food emulsifiers such as carrageenan act as a conditional inflammatory agent that magnifies any existing chronic inflammation of the intestinal tract provoked by pathogens. The hypothesis explains why carrageenan has been found to induce intestinal inflammation in most animal studies, but not all. For example, healthy neonatal pigs fed infant formula with carrageenan for 28 days had no effect on blood cytokine elevations, interleukin 1 beta, interleukin 6, interleukin 8, and TNF alpha. But they have not had any baseline inflammation and were not exposed to pathogens. So yeah, if you got gut inflammation, if you got gut dysbiosis, if you got a lot of bloating, diarrhea, constipation, you don't want to ingest carrageenan for sure. Food additives and intestinal inflammation in humans. Reports above of commonly used food additives causing intestinal inflammation in animal models have triggered investigations of how they may lead to inflammation in the human gastrointestinal tract. Although perfectly corresponding human studies are, of course, unethical to conduct, it's likely these mechanisms by which carrageenan induces inflammation in the human intestines are similar to animals and multifactorial. The stimulation of pro-inflammatory cytokines, disruption of the epithelial barrier, so cause leaky gut, and then interference of the innate mucosal immune responses to microorganisms. Community-level metabolic networks from the microbiome produce bioactive metabolites that establish a role in intestinal homeostasis and a healthy gut mucosal barrier. This barrier protecting the host from luminal antigens is composed of enterocytes, which are epithelial cells of your intestine, and the seal between them provided by the tight junctions cause leaky gut. When a healthy gut mucosa barrier, an individual maintains a homeostasis where the passage of nutrients, ions, and water across the intestinal epithelium to the mesenteric bloodstream is tightly regulated, while translocation of dietary antigens and components of the microbiome is prevented, and the active crosstalk between a diverse microbiome and the intestinal immune system leads to immune tolerance. So if you got a healthy gut barrier, you got a healthy gut. You got a healthy microbiome, you got a healthy gut barrier, and vice versa. Improved barrier function can lead to abnormalities in the expression of tight junction protein, which is zonulin. It may trigger immune activation and development of inflammatory disease and acceptable in individuals. So you have a diet, you have a healthy gut and unprocessed foods, you got inflamed gut and carrageenan and carbamexicellulose. So as you can see, healthy gut, unprocessed foods, you're fine. Inflamed gut, mucosal layer gets inflamed, epithelial barrier degrades, zonulin is produced, tight junctions are opened. That allows undigested food particles, which you may have allergic reaction to, microorganisms get into your bloodstream, and toxins are able to get through the gut when they normally could not, and do it to activate the immune system. So altered microbiome increases bacterial adherence, increases pro-inflammatory microbiota, increases altered microbial gene expression, increases immune stimulation, pro-inflammatory cytokines, and increases inflammation. This is when you have dysbiosis. So proposed biological mechanism, carrageenan and carbamexicellulose are processed food, so the erosion of the protective mucosal layer and abnormal expression of tight junction proteins. So there's a possibility that carrageenan, especially if you have dysbiosis, can lead to erosion of the mucosal layer, and in doing so produces and trigger the production of the protein zonulin, which opens up the tight junctions, allowing bacteria, undigested food particles, and toxins to enter your bloodstream, which your immune system reacts to. Undigested food particles, toxins, and microorganisms are then able to pass through the intestinal epithelium, resulting in the translocation of microbes and the overcolonization of pathobionts that can alter composition of the gut microbiome, triggering the activation of the immune system and development of inflammation. Both et al. Provided the first report of the inflammatory response of human intestinal epithelial cells to carrageenan exposure by demonstrating that carrageenan stimulates inflammatory cascade in colonic epithelial cells and pathway involving B-cell lymphoma and leukemia TIN gene activation and increased production of interleukin 8, a key pro-inflammatory cytokine. Results were supported when Choi et al. Used a human colonic adenocarcinoma cell line, HCT8, demonstrated that carrageenan led to the activation of nuclear factor kappa B, which subsequently increased the gene induction of interleukin 8. In addition, they reported that carrageenan triggered a disruption of the epithelial barrier, increasing the density of the tight junctional protein zonula occludens 1, causing a disarray in the distribution of ZO1 throughout the epithelium and decreasing gene expression of this tight junction protein. More recently, the group showed that carrageenan exposure triggered the expression of pro-apoptotic macrophage inhibitory cytokine 1, which is turned counteracted by MIC1-induced expression activating transcriptor factor 3. Carrageenan has been reported to interact with glycoprotein deleted in malignant brain tumors 1. DMBT1 functions as a pattern recognition molecule with a peptide domain capable of binding and aggregating a wide spectrum of bacteria. It was demonstrated to prevent the invasion of bacteria into the intestinal epithelial cells in vitro, which means in a test tube or in the lab. Carrageenan inhibits the bacterial aggregating function of DMBT1 via binding to a specific peptide that recognizes bacteria. It suggested that carrageenan disrupts the mucosal protection provided by DMBT1. So it literally causes your mucosa and your immune system to not react to pathogenic bacteria. There is the possibility that carrageenan is capable of disrupting the innate mucosal immune function provided by DMBT1, which can then trigger the initiation or perpetuation of inflammatory response to intestinal bacteria or bacterial antigens. In human cells, carrageenan has been demonstrated to trigger innate immune responses through pathways that involve BC110, TLR4, NFKB, and AP1. It leads to upregulation of TNF-alpha secretion. For example, Zhang et al. Just demonstrated that carrageenan-induced TNF-alpha secretion, which is a Th1 cytokine, is the main contributor to cellular damage in CACO2 monolayers exposed to carrageenan. However, researchers in the field note that in these studies, the degree of inflammation caused by carrageenan alone is low, while the inflammation generated through these pathways when a pathogen is additionally present is high, supporting the hypothesis that interaction is present in which carrageenan serves as a pro-inflammatory agent to amplify existing intestinal inflammation. In the view of the recent benchmark reports by Chessing et al. And Desai et al., more studies of the intestinal response to the widely used emulsifiers carrageenan and CMC, together with other features of Western diet, such as reduced dietary fiber intake, are eagerly awaited. It is noteworthy that the Food and Drug Administration regulations do not contain a definition of dietary fiber, but rather rely on analytical methods for measuring levels of dietary fiber in food. Therefore, an isolator of synthetic non-digestible carbohydrates such as carrageenan and CMC can be added to food and quantified as a dietary fiber, even though it does not provide the beneficial psychological effect to human health that dietary fiber should provide. Wow, okay, I did not know that. For example, carbomethylcellulose is listed among the 26 more common fibers being added to food and declared nutrition facts label as a dietary fiber. Widespread use of food additives. Patent in the United States in the 1930s, carrageenan was granted a generally recognized as safe status in 1959, and currently remains included as a food additive that holds a GRAS status in the Code of Federal Regulations of the United States. Carrageenan acts to thicken, stabilize, and emulsify a wide variety of foods consumed in the Western diet, including dairy products such as chocolate milk, ice cream, cottage cheese, sour cream, and yogurt, processed milk, meat, soy milk, almond milk, mayonnaise, and infant formula. Estimates regarding the average daily intake of carrageenan vary from 20 to 200 milligrams per day, are currently difficult to put in context without a standard for comparison within human studies or within animal studies. Alright, then they talk about inflammatory bowel diseases in the rise. So let's look at another study, where there was a conflict of interest. JVL, one of the authors, has participated in the advisory board for Nestle and has received speaking fees for research support from Nestle. Other authors declared no conflict of interest, which is interesting because Nestle uses carrageenan, so I guess the person was being honest. Hey? Maybe he's not going to get any kickbacks from Nestle anymore. So here we have an unpublished preliminary report. This has not been peer-reviewed, but it still is interesting. So they discuss about carrageenan coming from brown, family of polysaccharides from brown seaweed and red seaweed, and they talk about how it alters the gut microbiome. Okay, so let's discuss that. Some researchers have suggested that carrageenan may exert chronic low-grade inflammation defined by elevated systemic expression of pro-inflammatory cytokines in the absence of classical aggregates of immune cell infiltrates. In our data without increased inflammatory cytokines, the definition of carrageenan might be slightly inappropriate. These are consistent with most official reports. However, in the present study, 90 days of Carrageenan gavage promoted colitis-associated gut inflammatory symptoms in C. rodentum-treated mice, which has also been observed in our short-term tests. We therefore hypothesize that carrageenan provides a favorable environment for inflammation. Mucosal compartmentalization functions to minimize direct contact between intestinal bacteria and epithelial cell surface stratification. Bhattacharya et al. Reported in 14 weeks of carrageenan administration led to disruption of the mucosal surface in mice. Previously found that carrageenan can lead to destruction of the differentiated colonic layer via immune system effects, which suggests that the intestinal mucosal layer may be a target of carrageenan. Administration of carrageenan to germ-free mice did not result in low-grade inflammation, but as assessed by fecal LCN2 and pro-inflammatory factors, or any of the parameters related to mucosal thinning and altered localization of bacteria, even alteration of short-chain fatty acid contents. However, in the normal C57BL6 mice, carrageenan caused mucosal thinning, increased gut permeability, and decreased short-chain fatty acid production levels. These findings oppose the notion that carrageenan directly impacts the mucosal layer, and rather suggest that microbial dysbiosis may be a key driven factor of carrageenan-dependent inflammatory susceptibility. Having a high intake of carrageenan induced changes in the gut microbiome composition in mice, with increased relative abundance in several taxa belonging to the phylum Bacteroids, and decreased relative abundance of Proteobacteria and Firmicutes taxa. Now, reduction of Proteobacteria is a good thing. Most Proteobacteria are opportunistic. If you have too much Bacteroids, on the other hand, you look at the studies, they're supposed to make up about 20-30% of your gut. If they get a greater than that, they can't actually start eating the mucosal barrier, which we see mucosal thinning in diets that are high in carrageenan, supposedly. So that would make sense. Sheng et al. Found that carrageenan profoundly decreased the relative abundance of the anti-inflammatory bacterium Akkermansia mucophilia in the gut. Akkermansia mucophilia is an opportunistic probiotic / opportunistic bacteria that helps to maintain the mucosal barrier. It's like a symbiotic relationship. It eats worn parts of the mucosa, and your body secretes mucin to fill in those worn parts. So people with reduction of Akkermansia mucophilia in their digestive tract tend to suffer from heartburn, ulcerative colitis, Crohn's disease, leaky gut, reflux disorders like heartburn, like I mentioned earlier. So, things that increase Akkermansia would be like black rice, forbidden rice, organic pomegranate juice, organic cranberry, organic grapes. So we're now getting to they hinted about mucosal changes and microbiome changes and intestinal and health changes, with carrageenan being bacterial related in the state of one's gut, of whether you can eat carrageenan and be relatively okay, or you can eat carrageenan and it can cause massive problems. I suggested most people don't eat it anyway, because many people don't know that that they have dysbiosis until they have the straw that breaks the camel's back moment, right? And eating too much carrageenan could lead to that. Our study supports these findings where Akkermansia was significantly decreased in response to carrageenan treatment. Surprisingly, we found that carrageenan exposure did not decrease microbiota diversity. Yeah, that's surprisingly too. Increased total bacteria abundance. In general, individuals with chronic inflammation have lower bacterial diversity in their healthy counterparts. Yes, but it increased bacteria that could cause problems when they're overgrown, though. This may explain why, although it caused mucus defection but did not translate to colitis development compared to other food additives such as carboxymethylcellulose and polysorbate 80, the results gut microbiodiversity was decreased. Thus, carragenean's preservation of bacterial diversity may maintain a delicate balance in the intestinal microbiota and its environment. For example, some bacteria assist when inflammation and immunity show no negative changes. You would observe a decrease of relative abundance of gut proteobacteria. I mentioned that, which has a positive correlation to colitis. Yeah, proteobacteria have potent endotoxins which trigger inflammation in their cell walls, lipid polysaccharides. An increase in the abundance of rhodospiralaceae, which can enhance the cellular and humoral immunity of the body. So, carrageenan is bad, not as bad as polysorbate 80, because it doesn't completely reduce bacterial diversity and does decrease proteobacteria, because bacteroids and proteobacteria can compete with one another, but it can still cause problems and you should still avoid it. The analysis of gut metagenomes revealed an altered microbial gene profiles in carrageenan-treated animals. It confirmed a significant increase in relative abundance of KZ zymes belonging to the genus Bacteroids in response to carrageenan. variety of cazymes encoded by this taxon were regulated, including genes encoding glycoside hydrolysis and polysaccharide lysases. For example, increased expression of CBM32 and CBM40, which encode mucous membrane binding protein CE9 and CE11, degradation of mucin glycans and mucosal polysaccharide lysase and glycotransferase genes GH106 and GT4, which may allow switching to utilize host glucans of the intestinal mucosal layer. It's not good. Short-chain fatty acids contribute to the maintenance of immune homeostasis in the intestine and enhance intestinal epithelial barrier by assembly of triad junctions. That's true. We observed a significant upregulation of the genes Raminococci unclassified, which is capable of inhibiting short-chain fatty acid synthesis and increased abundance of Rumnococcus torcus group, Lactobacillus, Rumnocollostridium 5 and E. brachy group, which can synthesize short-chain fatty acids. Among these are torquis and L. bacterium 10. This enzyme is necessary for the hydrolysis of cellulose, starch, and mannan and contributes to production of high amounts of short-chain fatty acids, such as G5, G42, G15, G151, G36, G77, and G30, for which the gene contents were downregulated. Furthermore, this decreased fecal levels of short-chain fatty acids, including butyric acid and valeric acid, was confirmed. But butyric acid actually feeds your colonocytes, we mentioned earlier, your intestinal cells. However, the expression of MUC2, a building block of colonic mucus, KLF4, a transcription factor involved in barrier function, and TIF3, a mucosal repairing protein, were not affected by Carrageenan treatment. Therefore, based on changes in the microbial composition of cazymes and short-chain fatty acid synthesis gene contents, we speculate that Carrageenan treatment led to increased bacterial consumption of mucin-derived nutrients, which exceeded production of these compounds, hence destroying the integrity of the mucosal layer, which led to increased permeability or penetrability. We previously reported that once Carrageenan has a conversation with the immune system, mucosal damages intensify. Our latest findings may indicate that Carrageenan increases crosstalk between gut microbiota and the immune system by increased contact with the gut epithelium following mucosal damage. The observation that germ-free mice receiving fecal transplants from Carrageenan-treated mice also experienced mucosal thinning, increased production of short-chain fatty acids, and similar levels of inflammatory factors to conventional mice. Just relatively stable colonization by transplant microbiota with subsequent inheritance of similar phenotypes. Various probiotics have distributed clinical efficacy in patients with ulcerative colitis. Bifidobacterium strains have had several beneficial effects, including strengthening epithelial barrier function in human ulcerative colitis patients. The administration of probiotic Bifidobacterium longum NCC 2705 strain and fecal bacterium prosnitzi led to a partial recovery of gut microbiota and mucosal barrier destruction by ameliorating short-chain fatty acid deficiency, reinforcing intestinal barrier, and dampening intestinal permeability. Probiotic administration further limited the C. rodentum-induced immune reaction, metabolic impairment, and inflammation. So here we see that Carrageenan directly affects the gut microbiome in a mostly negative light, not as bad as polysorbate 80. So yes, Carrageenan is a seaweed extract from brown and red seaweed that is used to thicken up foods as an additive, whether it's lunch meat, processed meat, dairy products, plant-based dairy milks, and tofu, soy products. And I recommend that you avoid it as much as possible, especially if you're dealing with gut issues and intestinal inflammation and bacterial overgrowth or dysbiosis or yeast overgrowth or dysbiosis in the gut. Because as this information is shown, it will make inflammation in your gut worse. And make your dysbiosis worse too, likely. So make sure you check your labels. Even if it's organic now, it doesn't matter. It can still contain Carrageenan. So make sure, because of the food changes that were done under the Trump administration, U.S. Department of Agriculture, that you check your labels, even if they're organic, to see if they contain Carrageenan. Some toothpastes have Carrageenan in them as thickeners too as well. So check and see. And if you're dealing with any intestinal inflammation, inflammatory bowel disease, any dysbiosis, any gut issues whatsoever, I recommend that you do your best to completely eliminate Carrageenan within your diet, because it will make your symptoms likely worse, or it could be contributing to your symptoms. And giving up Carrageenan is something that you can do for your overall digestive health and for your overall health. I do my best to limit my ingestion of carrageenan as much as possible. I check my labels. I do my best. I'm not going to say that I haven't ingested it once every so often, but I do my best to try to avoid it, especially when I'm going to the store and picking up food to cook at home to my family. Hopefully one day carrageenan will be removed as a food additive. It's not good. And you can use native potato starch as a thickener. Works just as fine. And actually, potato starch has a resistant starch unless you have Klebsiella dysbiosis, which could be negative. But for most people, that little extra potato starch could be beneficial for the microbiome. That's resistant starch. All right, everybody. Take care. Have another stream soon.